Your test tomorrow covers sections 10.1 to 10.3. So we're solving systems using elimination, substitution, multivariable systems using row echelon and Gaussian. Remember, row echelon is like the same thing as back substitution. Okay, we're going to start with solving simple systems in two variables. For number 1, you are given 3x plus y is equal to 9 and x squared minus y is equal to -5. Now this is one that many people struggled with on your quiz for sections 10.1 and 10.2. Because you have an x squared there, your whole idea is to get what that y is from the other equation, so that way you can work with the x's and factor in order to solve. So you're going to first take that top equation of the 3x plus y is equal to 9, and you're going to solve it for y. So we're going to move that 3x over, subtracting it from both sides. That gives us y is equal to -3x plus 9. From there, you're going to take that -3x plus 9 and you're going to plug it in for y in that bottom equation. Now, the thing that a lot of people did on your quiz is you regretted to use the negative that's in front of that y. So you just plugged it in and didn't distribute. You have to distribute that negative into that -3x plus 9. So you're going to have x squared minus parentheses -3x plus 9, close parentheses, is equal to -5. You're going to distribute that negative into that -3x plus 9 first. So you're going to have x squared plus 3x minus 9 is equal to -5. Because there's an x squared there, you got to move everything over on the same side as that x squared. So add the 5 over. That gives you x squared plus 3x minus 4 is equal to 0. Your factors of -4 that add up to be +3 are 4 and -1. So this is going to factor to give you x plus 4 times x minus 1 is equal to 0. From here, take the x plus 4, set it equal to 0. Take the x minus 1, set it equal to 0, and solve them. You're going to move the 4 over by subtracting it from both sides. You'll get x is equal to -4. Move your 1 over by adding it to both sides. You'll get x is equal to 1. So now you have two x values. These aren't ordered pairs. You have to find the y values that go for each of those x values to give the ordered pairs. So you're going to start with the x is equal to -4. You're going to plug that in to solve for y. So I would use the y is equal to -3x plus 9. Plug that in there. So you're going to have y is equal to -3 times -4 plus 9. The -3 times -4 gives you 12. And 12 plus 9 gives you a y of 21. So that one is then the ordered pair of -4, 21. That's one of the two ordered pairs. From here, you're going to find the y for when x is equal to 1. So that's going to give you y is equal to -3 times 1 plus 9. Your -3 times 1 is -3. Plus 9 is 6. So when x is equal to 1, y is 6. So for this one, you have two ordered pairs that are solutions. The -4, 21, and the 1, 6. For number 2, you have 1/5 x minus 2/7 y is equal to 0, and 1/2 x plus 1/3 y is equal to -1. I don't like working with the fractions, so we're going to get rid of the fractions from the very beginning, which is what a lot of you did not do on your quiz, and that's when you struggled. So if you don't like working with fractions, get rid of them. Multiply the entire fraction or the entire equation by the least common denominator. Now, your least common denominator of your first equation is going to be different than your least common denominator of your second equation. That's perfectly fine. Your first or your top equation, your least common denominator between that 5 and that 7 is 35. On the bottom, between the 2 and the 3, you got 6. So that 35 times 1/5, or 35 divided by 5, gives you 7x. The 35 times -2/7 is going to become 5 times 2, 7, or 2 over 1, or 5 times negative 2, which is negative 10y, is equal to 35 times 0. That's still 0. On the bottom, 6 divided by 2, or 6 times 1/2 is 3x. 6 times 1/3 y gives us 2y. And 6 times negative 1 is negative 6. Now, easiest way to get rid of one of your variables here is to work with the y. They have opposite signs, and you only have to multiply that 2 by a 5 in order to make it a 10. So we're going to multiply that entire bottom equation by 5. So it's going to give us our top equation of 7x minus 10y is equal to 0, staying the same. That bottom equation turns into 15x plus 10y is equal to negative 30. You're going to combine like terms. Your y's cancel. That 7 plus 15 gives you 22x is equal to negative 30. Divide each side by that 22 and simplify your fraction. That negative 30 and that 22 are both divisible by 2, so that gives you negative 15 over 11. Now, easiest equation to work with is that top one. The reason why is because you're not going to have to change denominators when you plug that negative 15 over 11 in. So if we do that, we're going to have 1/5 times negative 15 over 11 minus 2/7 times y is equal to 0. Because your equation is 0, you don't have to change denominators at all. So you can just multiply that 1/5 times the negative 15 over 11. 5 becomes 1, the negative 15 becomes negative 3. So that's now negative 3 over 11 minus 2 over 7y is equal to 0. We want that negative 2 over 7y by itself, so we're going to add the 3 over 11 to both sides. So that gives you negative 2 over 7y is equal to 3 over 11. You're going to move that 2 over 7 or negative 2 over 7 over by dividing it from each side or multiplying by the reciprocal. So that's negative 7 over 2. That leaves you with y equaling negative 3 times negative 7, which is negative 21, over 11 times 2, which is 22. So if your x is the negative 15 over 11 and your y is your negative 21 over 22, the ordered pair that is your solution is negative 15 over 11, comma, negative 21 over 22. For numbers 3 and 4, you are solving using Gaussian elimination and giving the row echelon form of the system. For number 3, you have 2x plus 4y plus z is equal to 3, x minus 2y minus 3z is equal to 4, and x plus y minus z is equal to negative 1. I'm going to start by using the top and the middle equations. We are going to work with 2x plus 4y plus z is equal to 3, and x minus 2y minus 3z is equal to 4. Now, easiest thing to get rid of here would probably be your y's because they're opposite signs. So I'm going to multiply the bottom equation here by 2. The top isn't changing. It's going to stay the 2x plus 4y plus z is equal to 3. The bottom turns into 2x minus 4y minus 6z is equal to 8. We're going to combine like terms. Your y's cancel. You're left with 4x minus 5z is equal to 11. From here, we have not worked with that bottom equation yet, so I'm going to rewrite that one. X plus y minus z is equal to negative 1. And I'm going to work with one of the two ones that we already worked with. So I'm going to pick the middle because it's going to be the easiest to work with. So it's x minus 2y minus 3z is equal to 4. We have to get rid of those y's, so we're going to multiply that top equation by 2 to make it an opposite of negative 2y. So that's going to give us 2x plus 2y minus 2z is equal to negative 2, and x minus 2y minus 3z is equal to 4. Combine your like terms. Your y's cancel. You have 2x plus x, which is 3x. Negative 2z minus 5z, or 3z is negative 5z, and negative 2 plus 4 is 2. From here, you have two new equations that you're going to work with. One being the 4x minus 5z is equal to 11. The other, the 3x minus 5z is equal to 2. Now, if we just subtract these or change the signs on the bottom equation, our z's will cancel and leave us with x is equal to 9. We're going to take that 9, plug it into one of our new equations. I'm going to use the 3x minus 5z is equal to 2. So that's going to give us 3 times 9 minus 5 times z is equal to 2. Your 3 times 9 is 27 minus 5z is equal to 2. From here, we're going to move the 27 over by subtracting it from both sides to get negative 5z is equal to negative 25. We're then dividing each side by the negative 5, and we have that z is equal to 5. So our last thing to solve for is y. So we're going to take that bottom equation, so x, which is 9, plus y minus z, which is 5, is equal to negative 1. Just solve it for y. The 9 minus 5 is 4, so that's y plus 4 is equal to negative 1. From there, we move the 4 over by subtracting it from both sides, and we get that y is equal to negative 5. So we have 9, negative 5, and positive 5 to give us our order triple. So that's our solution. If we were to give the row echelon, we're going to take what we found first, which is that x is equal to 9. Then we're going to take what we plugged that into, which is the 3x minus 5z is equal to 2. And then we're going to take what the last equation was that we plugged into, which is the x plus y minus z is equal to negative 1. Tomorrow, on your test, you will be asked to solve and state the row echelon. If you give the row echelon, it should be the ones that you're working with. So it should be the first variable that you solve for, the equation that you plug into, and then the last equation that you plug into. And it should be in the order of greatest amount of terms to lowest amount of terms, top to bottom. If we look at number 4, we have x minus 3y plus 3z is equal to 4. 2x plus 3y minus z is equal to 15, and 4x minus 3y minus z is equal to 19. In this case, your y's are all opposites or the same term. So we're going to start by taking the first two equations and eliminating the y. So we have x minus, let's do it the right color, x minus 3y plus 3z is equal to negative 4. And 2x plus 3y minus z is equal to 15. Our y's are going to cancel and leave us with 3x plus 2z is equal to 11. And then we're going to start all over again, use that bottom equation of the 4x minus 3y minus z is equal to 19 and the middle, so that way they're opposites. So you have 2x plus 3y minus z is equal to 15. Again, combine your like terms, or your y's cancel. You're going to be left with 6x minus 2z is equal to 34. From here, you're going to use the two new equations that you have. So that's that 3x plus 2z is equal to 11, and the 6x minus 2z is equal to 34. Your z's are opposites, so they cancel. You're going to be left with 9x is equal to 45. Divide each side by that 9, and you get that x is 5. So if you want, put like a little arrow next to that or something, so that way you know that's what you're using in your row echelon.
The 9x equals to 5.
The x is equal to 5, because that's the first variable that you solve for. From here, I'd plug this into the 3x plus 2z is equal to 11 to get what z is equal to, because it's smaller numbers, so I'm going to work with that one. So we're going to have 3 times x, which we said is 5, plus 2z is equal to 11. The 3 times 5 is 15, plus 2z is equal to 11. we move the 15 over by subtracting it from both sides. We get 2z is equal to negative 4. Then we divide each side by the 2, and we get that z is negative 2. So lastly, we're going to solve for y. I'm going to use the middle equation because y is positive there. It really doesn't matter which one you use. I think in your answers I used the top one, but like I said, doesn't matter. We're going to have 2 times x, which is 5, plus 3y, that's what we're finding, minus z, which is negative 2, is equal to 15. So we used this one. This is going to give us 10 plus 3y plus 2 is equal to 15. Your 10 plus 2 is 12, so that's 3y plus 12 is equal to 15. Move your 12 over to subtract it from both sides, so you get 3y is equal to 3. Then divide each side by the 3, and you get that y is 1. So for your order triple, you have 5, 1, negative 2. For your row echelon, you had the 2x plus 3y minus z is equal to 15 that you used. You also had the 3x plus 2z is equal to 11, and x is equal to 5. Your next 2 questions tell you to show if the ordered triple is a solution to the system. For number 5, you're given 4x plus 4y plus z is equal to 24, 2x minus 4y plus z is equal to 0, and 5x minus 4y minus 5z is equal to 12. I'm going to do this over here. So this top equation, we're going to have 4 times 4 plus 4 times 2 plus 0 is equal to 24. That gives us 16 plus 8 is equal to 24. And that's 24 is equal to 24. So that gives us a true statement. We're going to move to the middle one now. The middle one, we have 2 times x, which we said is 4, minus 4 times y, which is 2, plus 0 is equal to 0. 2 times 4 is 8. Negative 4 times 2 is negative 8. 8 minus 8 is 0. So that gives you a true statement as well. Check your last one now. You have 5 times 4 minus 4 times 2 minus 5 times 0 is equal to 12. That negative 5 times 0 does cancel out. 5 times 4 is 20. Negative 4 times 2 is negative 8. 20 minus 8 gives us 12. And 12 is equal to 12. So because all 3 of these give you true statements, this order triple is a solution. For number 6, we have negative x minus 5y plus z is equal to 17. Negative 5x minus 5y plus 5z is equal to 5. And 2x plus 5y plus 3z is equal to negative 10. The order triple that we're given is negative 1, negative 4, negative 4. So top equation is going to give us the opposite of negative 1 minus 5 times negative 4 plus negative 4 is equal to 17. This simplifies to give us 1 plus 20 minus 4 is equal to 17. This then simplifies to give us 21 minus 4, which is 17, is equal to 17. So that's true. Move on to your next one. Your next one, you have negative 5 times negative 1 minus 5 times negative 4 plus 5 times negative 4 is equal to 5. This simplifies to give you 5 plus 20 minus 20 is equal to 5, which is 5 is equal to 5. This is also a true statement, so we'll move to the third. That gives us 2 times negative 1 plus 5 times negative 4 plus 3 times negative 4 is equal to negative 10. This then simplifies to give us negative 2 minus 20 minus 12 is equal to negative 10. Your negative 2 minus 20 is negative 22, minus 12 is negative 34. This is not equal to negative 10. So because this one gives you a false statement, it is not a solution. For number 7, 8, and 9, you are using back substitution to solve each system and writing your answer as an order triple. For number 7, you're given x minus y plus 2z is equal to 22, 3y minus 8z is equal to negative 9, and negative z is equal to 3. We're going to start with that negative z is equal to 3 and divide each side by the negative 1. This gives you that z is equal to negative 3. So that's one of your answers. From there, you're going to plug this to the middle equation. So that's 3y minus 8 times negative 3 is equal to negative 9. Your negative 8 times negative 3 gives you 3y plus 24 is equal to negative 9. You're going to subtract the 24 over, and that'll leave you with 3y is equal to negative 33. Divide each side by the 3 that's in front of that y, and you have that y is equal to negative 11. You're going to take that negative 11 and that negative 3, and you're going to plug them both into that top equation to solve for x now. So that's going to give you x minus negative 11 plus 2 times negative 3 is equal to 22. Double negatives turn to positives, so that's x plus 11 minus 6 is equal to 22. 11 minus 6 gives us 5. We're going to move that 5 over by subtracting it from both sides, and we are left with x equaling 17. So if x is 17, y is negative 11, and z is negative 3, that gives us the order triple of 17, comma, negative 11, comma, negative 3. For number 8, we have 4x minus 2y plus z is equal to 8, negative y plus z is equal to 4, and z is equal to 11. We're going to take that 11, plug it in for z in that middle equation, so that's going to give us negative y plus 11 is equal to 4. We're going to move the 11 over by subtracting it from both sides, so we get negative y is equal to negative 7. We divide each side by that negative 1, and we have that y is positive 7. So we're now going to take both of these and plug them into that top equation to get 4x minus 2 times 7 plus 11 is equal to 8. Your negative 2 times 7 is negative 14. Negative 14 plus 11 gives us negative 3. So that's 4x minus 3 is equal to 8. We're going to add the 3 over first to get 4x is equal to 11. Then divide each side by the 4. And we have that x is 11/4. So we have an x, a y, and a z. So we write it in the form of x, comma, y, comma, z to give us 11/4, comma, 7, comma, 11. For number 9, you have x plus 2y minus 3z is equal to negative 3, negative 5z plus 4z, or sorry, negative 5y plus 4z is equal to 13, and 2z is equal to 5. You're going to be working with fractions with this one. First thing you're going to do is take that 2z is equal to 5 and solve it for z. So we're going to divide each side by the 2, and you get z is equal to 5 over 2. Take this, plug it into that middle equation. You have negative 5y plus 4 times 5 over 2 is equal to 13. Your 2 simplifies with that 4 to become 2 times 5, which gives you negative 5y plus 10 is equal to 13. Subtract your 10 over. That gives you negative 5y is equal to 3. Divide each side by that negative 5, and you have that y is negative 3/5. You're now going to take that to those 2 and plug them into that top equation to solve for x. So that's going to give you x plus 2y, so 2 times negative 3 over 5, minus 3z, which is 5 over 2, is equal to negative 3. We're going to multiply first. That's going to give us x minus 6/5 minus 15 over 2 is equal to negative 3. Now, I don't want to work with the fraction, so I'm going to multiply everything by my least common denominator, which is 10. That'll give us 10x minus 2 times 6, which is 12. 10 divided by 2 is 5, so 5 times negative 15 gives us negative 75 is equal to 10 times negative 3 is negative 30. Combine your like terms. That's 10x minus 87 is equal to negative 30. Add your 87 over. That gives you 10x is equal to 57. Then divide each side by your 10. And you have x is 57 over 10. So you have an x, a y, and a z. So you can give the order triple as 57 over 10, comma, negative 3/5, comma, 5 over 2. For your last question, you have 2x plus 3y plus z is equal to 6, negative x plus 4y minus z is equal to 0, and 4x plus 6y plus 2z is equal to 12. I'm going to use the top two equations and eliminate our z's since they're opposites. So that's 2x plus 3y plus z is equal to 6, and negative x plus 4y minus z is equal to 0. We're going to combine like terms. Our z's cancel. We have x plus 7y is equal to 6. I'm then going to use that bottom equation with the middle equation to still eliminate z's. So we have 4x plus 6y plus 2z is equal to 12. And negative x plus 4y minus z is equal to 0. That bottom equation we're going to have to multiply by 2. So that top equation stays. Your bottom equation becomes negative 2x plus 8y minus 2z is equal to 0. We combine like terms. Our z's cancel. We're left with 2x plus 14y is equal to 12. You now have two new equations that you're going to work with. That's the x plus 7y is equal to 6, and the 2x plus 14y is equal to 12. We're going to eliminate those x's and multiply that top equation by negative 2. So it becomes negative 2x minus 14y is equal to negative 12. That bottom equation stays 2x plus 14y is equal to 12. You should see here that every single term that you have is opposites. So they all cancel out, which means you have 0 is equal to 0. This does not mean anything other than infinitely many solutions. If you were left with something like 2 is equal to 0, then I could understand you saying that there's no solution. But that's not the case here. Or if it's 0 is equal to 14, still no solution. But that's not the case here. We have 0 is equal to 0. That is a true statement. So because it's a true statement, we have infinitely many solutions.